All right, now we discussed how to deal with tied ranks in the previous example, but sometimes we have just too many of those tied ranks, and so we need to come up with a different procedure. And when we have ordinal variables that are cross-tabulated, meaning that we want to look at associations between more than two um, uh, nominal variables or ordinal variables. And 12.7, table 12.7 is an example of this in the textbook. And the essential idea is that we want to talk about agreements and inversions, and those are both discussed really well in the literature or in the textbook. And so NA is the number of agreements, and Ni is the number of inversions that we have. And the gamma coefficient is the result of dividing the number of agreements subtracted from the number of inversions, okay, by the sum of the agreements and the inversions. Okay, and so this is how we calculate gamma. Now, once we want to calculate the significance or test the significance of the gamma coefficient, we have to convert G to Z and then compare that to a critical value that's shown in table A in Appendix Z, Appendix C. And the way I do that, I calculate Z by taking gamma and then multiplying it by the square root of the number of inversions plus the number of agreements, and then dividing that by the product of 1 minus gamma squared times n. And when I do that, that's going to give me a z-score that I can look up in Table A of Appendix C. Now, in terms of the assessments that you're going to be doing for this module, you're not going to actually be computing gamma, which is why I kind of glossed over the ways to compute it in the slides. What you are going to have to do is know when it's appropriate to use gamma versus when it's appropriate to use the Spearman rank order correlation coefficient.